NEC section 250.30 requires that the frames of portable generators be bonded to the frame of the structure or equipment it is supplying. This requirement ensures that any fault current that may occur in the generator will be safely conducted back to the source. The lack of a bond between the generator frame and the conductor of the 120-volt winding could create a hazardous condition. If a fault were to occur in the generator, the current could flow through the user and into the ground, potentially causing serious injury or death. Therefore, it is important to ensure that any portable generator is properly bonded to the frame of the structure or equipment that it is supplying. Bonding the generator frame is crucial for electrical safety. Without it, a ground fault can energize the generator's frame, creating a shock hazard. The National Electrical Code, or NEC, provides specific guidelines to mitigate such risks. Let's delve into the key aspects of grounding portable generators. Firstly, understand the purpose of grounding. Grounding provides a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers and fuses. Without proper grounding, fault currents might not be high enough to trip these devices, leaving the generator frame energized and dangerous. Secondly, familiarize yourself with NEC section 250.30, which specifically addresses grounding requirements for generators. It stipulates that the generator frame must be connected to a grounding electrode system. This system typically consists of a ground rod driven into the earth or connection to the building's grounding electrode system. Thirdly, consider the different types of grounding configurations. While some generators have a bonded neutral, meaning the neutral conductors connected to the frame, others are unbonded. The NEC addresses both scenarios. For separately derived systems, which is often the case with portable generators, the neutral is typically bonded at the generator. Fourthly, when connecting a portable generator to a building's electrical system, a transfer switch is essential. This switch isolates the generator from the utility power, preventing backfeeds, which can be hazardous to utility workers and damage the generator. The transfer switch also ensures that the grounding system is properly maintained. Fifthly, portable generators used to supply cord and plug-connected equipment do not necessarily require connection to a grounding electrode system if certain conditions are met, as outlined in NEC Article 250. These conditions usually involve specific overcurrent protection and equipment leakage current limitations. Sixthly, the grounding electrode conductor, or GEC, connects the generator frame to the grounding electrode. The size of this conductor is determined by NEC Table 250.66 based on the size of the generator's conductors. Seventhly, regularly inspect the grounding system to ensure it is intact and functioning correctly. Check for loose connections, corrosion, and damage to the grounding conductors and electrodes. Eighthly, be aware of the specific requirements for different types of generators and applications. For example, generators used in construction sites may have different grounding requirements than those used for standby power in residential settings. Ninthly, always consult with a qualified electrician to ensure that the generator is properly grounded and that the installation complies with all applicable codes and regulations. Electrical work can be dangerous, and it's best to leave it to the professionals. Tenthly, remember that grounding is not the same as bonding. Grounding connects the electrical system to the earth, while bonding connects metallic parts of the electrical system together to create a low impedance path for fault current. Both are essential for electrical safety. Consider a scenario where a portable generator with an unbonded neutral is used to power a construction site. The generator's frame is not connected to a grounding electrode system. A worker accidentally damages a cord, exposing a live conductor. If the generator frame is not properly grounded, the fault current may not be sufficient to trip the circuit breaker. The worker could then come into contact with the energized frame, resulting in a severe electric shock. This scenario highlights the importance of proper grounding. Now, let's discuss the sizing of grounding conductors. NEC Table 250.122 provides the minimum size of equipment grounding conductors for grounding raceway and equipment. This table is based on the rating of the overcurrent protective device protecting the circuit. For example, If a 20-amp circuit breaker protects the circuit, the minimum size of the equipment grounding conductor is 12 American wire gauge copper. It is important to note that the equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. This ensures that the impedance of the grounding path is low, which is essential for effective fault current protection. In addition to the equipment grounding conductor, a grounding electrode conductor is also required to connect the generator frame to the grounding electrode. The size of this conductor is determined by NEC Table 250.66. This table is based on the size of the service entrance conductors or, in the case of a generator, the generator output conductors. For example, if the generator output conductors are 2 American wire gauge copper, the minimum size of the grounding electrode conductor is 6 American wire gauge copper. It is crucial to use the correct size grounding conductors to ensure that the grounding system can effectively carry fault current back to the source. Undersized grounding conductors can overheat and potentially cause a fire. Proper grounding also helps to reduce electromagnetic interference or EMI. EMI can disrupt the operation of sensitive electronic equipment. By providing a low impedance path for fault current, grounding helps to minimize the generation and propagation of EMI. When selecting a portable generator, consider its grounding configuration. Some generators have a bonded neutral, while others have an unbonded neutral. A bonded neutral generator has the neutral conductor connected to the generator frame. An unbonded neutral generator does not have this connection. The choice between a bonded and unbonded neutral generator depends on the specific application. For example, a bonded neutral generator is typically used when the generator is connected to a building's electrical system through a transfer switch. An unbonded neutral generator is typically used when the generator is used to power cord and plug connected equipment. Always follow the manufacturer's instructions for grounding the generator. The manufacturer's instructions will provide specific details on how to properly ground the generator for different applications. Ignoring the manufacturer's instructions can result in an unsafe installation. Portable generators are a valuable source of power, but they must be used safely. Proper grounding is essential for electrical safety. By following the NEC guidelines and the manufacturer's instructions, you can ensure that your portable generator is properly grounded and that you are protected from electrical shock hazards. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest NEC requirements to ensure that your electrical installations are safe and compliant. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. It is important to check with your local authorities to determine the specific requirements in your area. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone. Remember to always turn off the generator before refueling it. Gasoline is highly flammable, and refueling a hot generator can be extremely dangerous. Allow the generator to cool down completely before adding fuel. Store gasoline in approved containers and away from heat sources. Never operate a generator indoors or in enclosed spaces. Generators produce carbon monoxide, a deadly gas. Ensure that the generator is located in a well-ventilated area, away from windows and doors. Install carbon monoxide detectors in your home or building. Test the detectors regularly to ensure they are functioning properly. Do not overload the generator. Overloading can damage the generator and create a fire hazard. Check the generator's wattage rating and do not exceed it. Use appropriately sized extension cords. Undersized extension cords can overheat and cause a fire. Inspect extension cords regularly for damage. Replace damaged extension cords immediately. Keep the generator clean and dry. Dirt and moisture can damage the generator and create an electrical hazard. Store the generator in a dry place when not in use. Follow all safety precautions when operating a generator. Pay attention to warning labels and instructions. If you are unsure about any aspect of generator safety, consult with a qualified electrician. Protecting yourself and others from electrical hazards is paramount. A properly grounded portable generator is a vital component of a safe electrical system. By understanding the principles of grounding and following the NEC guidelines, you can minimize the risk of electrical shock and ensure the safe operation of your generator.